Good morning. I hope everybody's still doing well and healthy, and I miss you all and can't wait to see you again. So a couple of things before I get started on the notes for today is one, be looking for an announcement in the next few days about when the end of school will happen. I do not know, but I do think they'll be announcing that pretty soon. And also look for an announcement about semester exams. I don't think we'll be having them, but you should be looking for an announcement about that because I'm not sure yet in the next day or two. So the last couple of weeks we've been talking about exponential functions, how to graph those, their transformations, how to write equations. And what we're going to start looking at now is what's the difference in a linear function and an exponential? If something has constant growth or exponential growth, what does that mean? And what's the meaning of those words? And so we're going to be looking at what do their equations look like? And if I give you some tables of values, can you identify if it's linear, exponential, or neither one? So that's what we're going to look at today. We should be finishing up with exponentials this week, beginning of next week, and then we'll talk about some type of test middle of next week. All right, so linear functions, we started that way back 7th, 8th grade. We know slope-intercept form is the y equals ax plus b, and we know that a is our slope and b is our y-intercept. And if it's linear, this rate of change or this slope is going to be constant. Okay? Exponential, a is what we call our initial value. So when x equals 0, b is our base, and x is our exponent, which we've already talked about in the past. All right, so with exponential functions, you're able to both have either a positive or a negative rate of change, just like you do with linear. We're going to look at a couple of new terms. Positive rate of change is called exponential growth. And to get exponential growth, we know that b has to be greater than 1. And then a negative rate of change is called exponential decay. And here we know it has to be less than 1. Okay, so then when we're talking about what's exponential growth and exponential decay, looking at pictures of that. So if we're looking at a line, okay, this is a graph of a positive line, what we would call positive, and that's where it's increasing from left to right. So this graph is exponential. This one is going down, so this would be exponential decay because it's decreasing from left to right. This one would be a negative line because it's decreasing from left to right. And this one would be exponential growth because it's increasing from left to right. So this is exponential growth, exponential decay. And here we have growing and decreasing with lines, but we can see the difference in their types of graphs. So what we're going to look at now are some, and I'll post pictures of these, tables and being able to decide if it's linear, exponential, or neither one. And this is something that shows up on that 10th grade test. I know we don't have to take it this year, but those of you who are freshmen may have to take it next year. I think that's still up in the air if you'll have to or not, but we'll be prepared either way. All right, so we're going to look. With linear, the constant rate of change, that slope, is what we're adding by. This difference has to be the same. So the difference here from 4 to 7 is 3. The difference from 7 to 10 is 3. So this difference is the same, while this difference is the same. We're going up by 1 each time. So that would be a rate of change of 3 over 1. So this one would be linear. Okay, on this one, this difference is 1. But this difference, so from 6 to 18 is, if we're talking about here, we were adding. So I need to put the sign there. So if I add here to how to get from 6 to 18, that would be adding 12. But to go from 18 to 54, that's not 12, right? So that difference is not the same. Okay, so this is going up by 36. And then again, so this is not going to be linear because what we're adding by each time, that difference is not the same. So then I'll say, okay, what would I multiply by 6 to get 18? So that would be multiplying by 3. And 3 times 18 is 54. And 54 times 3 is 162. So because we are multiplying by the same thing each time, then this would be exponential. And you'll notice in linear, right, we're increasing here. This is increasing, but this is increasing at a much faster rate than what this is. Okay, so when we look at this example, we look to see what the differences are first. I always check that first. So the difference here is I'm going down by negative 20. Same thing here. Same thing here. So this would be linear, and these are all going up by 1. So that difference is the same. Okay, let's look at this one. So here we're all going up by 1. All right, so over here, the difference in 32 and 16, that would be going down by 16. Here, this is going down by 8. So this is not linear because that difference is not the same. So if I look at what would I multiply by, so I could take 16 divided by 32, that's 1/2. So this is multiplying by 1/2. 8 divided by 16 is 1/2. 4 divided by 8, that's 1/2. 2 divided by 4, that's 1/2. So I'm multiplying by 1/2 each time. So this would be exponential. All right, let's look at another one. All right, so here we're going up by 1 each time. All right, here the difference is if I go from -1 to -8, then I am adding by 7. Here I'm adding by 1, so it's not linear. Okay, and then here I have -1 divided by -8, so I'm multiplying by 1/8. 0 divided by -1 is 0, so here I'm multiplying by 0. Okay, so this is not the same, and so it's not exponential, so this would be neither. Okay. So what I'm looking at is, without graphing, can you look at a table of values and determine if it's linear or exponential or neither? So you look at these differences should be constant. Okay, what we're looking at today, whether it be 1 or 2 or whatever it is. And so you're looking in your y values. Are you adding by the same number each time? Are you multiplying by the same each time? Or if neither one, then it's neither. If you're adding by the same number each time, then it's linear. If you're multiplying by the same number each time, then it's exponential. If we think about these as patterns, okay, this would be an arithmetic pattern. Arithmetic is always linear. or sequence. And if we look at this is geometric, which is always represents exponential. So today we're going to look at being able to do that, and then just a little investigative activity about the differences in growing with linear functions and exponential functions and what that means. So if you have any questions, just let me know. Hope you have a good day and all is well. Can't wait to see you again.